Okay, you are going to get the quick version of the notes over arithmetic sequences, which includes recursive and explicit. We started off by trying to kind of draw this comparison that when you are finding a sequence, for example, the number of sides to a star is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what would happen here is this is 10, 20, 30, 40, 50, right? And if you were to graph that, 0 stars has 0 sides, and 1 has 10, and 2, and 3, and 4, and 5, and so on. Obviously, we can kind of find a slope here. We find this reoccurring pattern of that's going up 10 as these go up 1, and that's why your slope would be 10, right? And then even your y-intercept would be 0. Okay. Then same thing here. Number of circles, and then actually, so n is just this, and there would be 2 circles, right? And then n is 2. Now we have 1, 2, 3 of them, and so on and so forth, right? So again, we could graph this, x is 1, y is 2, 2, 3, 3, 4, 5, and so on. And so in this scenario, our y-intercept would move down, not be 0, it would be right there. So there we go. And the reason for that is if we were to go backwards to the 0th term or the 0 term, we would have a circle, right? There, it would be 1 because it follows this pattern, right? Similarly here, number of rows n, so this is 1 row. How many dots is there? Well, that's 2, 4, 6, 8, 10. Again, the 0th term would be 0. You have 0 rows, would look like that. So again, we have this thing. Right. Okay. So that was 2 minutes of saying, hey, we're kind of building a case here for slope. And then we tried to make it a little bit more complicated and say, hey, can you think through this as far as, hey, what if you had this situation where you have a molecule of water? And a molecule has 3 atoms. This particular molecule, since it's water, has 3 atoms. And so it says use the pattern to determine the number of atoms in 24 molecules. And so the idea is that n would equal 24. And so how many atoms would that be? Well, so let's try this. So this is 3, 6, 9, 12, 15. And so what's going on here is we're just doing 1 times 3, 2 times 3. And so we could do 24 times 3, and let's see, what is that, 72? Yeah, so that's how many atoms there would be. Now, oddly enough, this is also slope, right? This is just, a slope of 3, right? You're going up 3 atoms per 1 molecule. All right, so now there's some blanks. And what are these blanks? Well, now we're talking about, finally, what is a sequence, because, we're talking about arithmetic sequences today. So a sequence is an ordered list of numbers that often forms a pattern. By the way, there is no significance to this being bolded. I just sometimes when I zoom in and out, my pen decides to be dynamic. Anyway, so a sequence is an ordered list of numbers that often forms a pattern, period. Each number is a term of the sequence. And in a specific type of sequence, an arithmetic sequence, the blank, the difference between any 2 consecutive terms is a constant. And that constant is called, and I am going to change colors because this is significant, the common difference. So we want you to be aware that that is a thing. Specifically, the common difference here would have been 3, 3, 3, right? That's the common difference, okay? So how do you find an arithmetic common difference? Well, determine what you need to add or subtract to get from term to term. I mean, that's what would have happened up here. We didn't write it out. We wrote it out visually as opposed to the numbers right here. But if I just started writing 3, 6, 9, 12, 15, you might have said, well, hey, that's a difference of 3 each time. And I'd have said, yeah. So if it's a constant number, meaning if it's 3 every time, then the sequence is arithmetic. And if you're like, well, what's the difference? Well, we will eventually have geometric sequences, and those will not be arithmetic. So as you're looking at this, I mean, 12, 8, 4, 0, you can pretty clearly see we're going down by 4. So essentially, you have added -4 to each term to find the next term, making our common difference -4, okay? So we have established what is an arithmetic sequence. It's basically a sequence of numbers that you're going up by a common difference, and that common difference is constant. It's the same number every time. So now we have a new word, recursive. I'm going to put him in a box because he's special. A golden box even. Shiny golden box. Yay. A recursive in mathematics just basically means to repeat. You repeat a process over and over again using the output of each step as the next input. So this is where now we're connecting the dots back to this idea, okay? We used, what did we say? We used the output to find the next input. So we said, okay, there's 2, okay, and there's 2 2s. This was the output, and we use it as the input over here, so to speak. And they say, hey, that's basically slope-intercept form, right? Because this is our output, and that is our input. M is the common difference, and B is the 0th term, or the y-intercept. And if you're like, wait, 0th term, that sounds familiar. Yes, I talked about it here and here, right? Great. So slide back over here. And then if we were to read this kind of all as one idea, to put into slope-intercept form, y equals mx plus b, the output equals the common difference times the input plus the 0th term, and that's the term that comes before the first term. So pause here for a moment and read these with me. A recursive formula is a formula for the next term depending on the previous term. Recursive formula is a formula for the next term depending on the previous term. And then an explicit formula is a formula for any term depending on the term number. And you're going to see that example. You're going to see what we're talking about down here. So to continue my color coding, this is recursive, okay? And this down here, this is going to be explicit. Lots of students love to make jokes about explicit, like lyrics can be explicit. Yay. Okay, I don't know if those are exactly the same meaning in this situation. So, what we're going to do, step 1, determine the first term. Now, as I go through this part, it's going to feel a little bit floating in the air, doesn't make complete concrete sense, but then we're going to attach it to some concrete right here, okay? So don't freak out. You determine the first term. You want to know what's a sub 1. You want to figure out the common difference, d, and you substitute it into this formula. A sub n, meaning a term we don't know, so like it could be a term into the future, so to speak. or technically the past, right? It's just a term we don't know. And then what happens next in the formula is we use a sub n minus 1 plus the common difference. Okay, so if we were to kind of rewrite this guy using n equals 1, check it out, n right now equals 1, well then we would get a sub 1 minus 1 plus d, and that could be rewritten, I'm going to rewrite this whole thing as a sub 1 equals a sub 0 plus d. If that feels weird, remember this is kind of like our y-intercept, and this is basically our slope, right? So now, okay, let's make it more concrete. The first term, a sub 1, is negative 20. Our common difference is plus 15, plus 15, plus 15. So 15, right? So then we could write our recursive formula as a sub n equals a sub n minus 1 plus 15. And then we could actually find a sub 1. I mean, we already know it right here. But a sub 1 is going to equal a sub 0 plus 15. And then now technically we could solve for a sub 1 or a sub 0. Sorry, I shouldn't have said we could solve for a sub 1 because we know it. We could solve for a sub 0 should we want to. And it would look like this. We know a sub 1 is negative 20. We don't know a sub 0 plus 15. You would subtract 15 from both sides, and you get that the 0th term, or the y-intercept, basically, is negative 35. Now, it doesn't take a genius to figure out that going this direction, going to the left, we're going down, so you would subtract 15 as opposed to adding going this direction. There's one reason why I did it in a different color is because I'm showing you, hey, we were here, and to go backwards, we would be there. Okay? So, that's the whole thing. Let's slide over here and try it again. Basically, if you think you get it, why don't you try this on your own real quick? If you don't think you get it, that's okay. Just do it with me now. The first term is 7. The common difference, well, let's see. Plus 3, yep, it's pretty much plus 3 every time, so 3. So here is our recursive formula right here. A sub n equals a sub n minus 1 plus 3. Okay? Now, to find a sub, so what is a sub 1? It's going to be a sub 1 minus 1 plus 3, which a sub 1 is equal to a sub 0 plus 3. We know a sub 1 is 7. This is supposed to be a 0. And if we subtract 3, then a sub 0 equals 4. So, just like we did on the other one, if we go back 3, then we get 4. Now, by the way, this part down here is not necessarily why we're doing this, but I just wanted to kind of follow what's going on there, okay? And the main takeaway is this right here. Oops, I thought I chose the highlighter. This is the main takeaway right there, okay? In fact, I'll zoom out and I'll write it way up here. Recursive formula is really a sub n equals a sub n minus 1 plus d. That's the main takeaway, okay? Let's make it all pretty. It's not very pretty. Let's try again. Sure, pretty enough. Okay. Now, zooming in for the explicit formula. So we're going to follow this little table real quick because it's going to hopefully help you come upon the explicit formula yourself. So if we were describing a sequence, and we had different spots, and we said, okay, in the first position is, well, the first term, and the first term would be called a sub 1. Notice terms are called like a sub n, until we actually know which position they're in, right? If you see someone running a race, you don't go, oh, look, there's first place, until you know they're in first place. Until then, they're just in a position. Okay, great. So you write it using A1. A sub 1 is just going to be whatever it is. So in this really specific situation, A sub 1 is 4, okay? Now, moving on to the second position. That would be the second term. So what you do, as you imagine you would do, is you find the second term by taking the first term and adding the common difference. Now let's watch them do that. Here's the first position. The first term is 4. And they're adding 1 times 3. Okay. That's 7. We're okay with that. We can just write 7 there. Let's go to the next one. Third position, we call the third term. And now it's getting a little interesting because here's what they're doing. They're not just adding the common difference. They didn't do this. They didn't say 2t plus d. They're saying, let's make it simple. Let's add 2 times d. And what are they adding it to? They're adding it to the first term. So the first term is 4. And if you were to add it by the common difference twice, you would get 10. And that makes sense. If I'm over here at 4, and I add 3, I get to the second term. If I add 3 twice, I'm at the third term, which we just did. Okay, maybe you're starting to get this. Let's find out. We're going to the fourth term. In the fourth position, we're going to add the first term by the common difference 3 times. First term, common difference, 3 times, and we get 13. Okay, so we could figure out that this is obviously 16, but what about, let's say, the millionth term? Do you know that one? I don't know that one, but we could figure it out. In the millionth or the 50th term in position, we would have a sub 50 or a sub million, which would be weird to say. Which is weird to say, okay. And here's what we're going to do. This is going to be n plus 1. Nope. I did this in class too. It's n minus 1. Why is it n minus 1? Well, hey, this guy was n, and how many did we multiply it by? N minus 1. This guy was n. How many did we multiply it by? N minus 1. So, over here, this is also n minus 1. And we don't know what this is going to be because we don't know which position we're in, right? But if you were going to find that millionth term, here's your formula. This is the explicit formula, okay? So I'm going to keep going and talking and like do an example, but this is the major takeaway, okay? That's the formula. All right, let's zoom out. Let's go back up here. So here would be the steps that you would take. Again, this is going to be the less concrete one. This one will be the more concrete one. You would first determine the first term because you need it. You would find the common difference because you need it. And then you would just substitute n minus 1 right there. Okay? So let's do this. Here's the first term. We need it. The common difference, how do you get from negative 20 to negative 5? You add 15. From negative 5 to 10, you add 15. From 10 to 25, you add 15. So our common difference is 15. So what we're going to do is a sub n is the first term plus n minus 1 times 15. This right here is the explicit formula for this arithmetic sequence, okay? So, step 2, the explicit formula, they're saying, all right, what if you wanted to find the 20th term? Well, let's do it. You would do negative 20 times 15, or I'm sorry, plus 15 times n minus 1. Well, hold up. N is 20, so this is 20 minus 1. So what it ends up looking like is this, negative 20 plus 15 times 19. Why 19? Because 20 minus 1. So let's see, off the top of my head, I don't know, 15 times 19, 45, we get a 9, and a 0, and a 19, and a 5, and an 8, and that's negative 20 plus 285 is 265. So if you were to take this, if you were to start at negative 20 and add 15 and find the 20th position, it would be 265. So down here, this might shake you up a little bit, but this was the explicit formula, right? Notice how similar it is in structure to that. And if you think, no, not really, well, watch this. A sub n equals a sub 1 plus d times n minus 1. If you were to subtract a1 from both sides, you get that. And isn't that a whole lot like this? Right? Pretty much, like I said, in structure, look, they line up the same, right? Even like the minuses and the minuses, right? So, what does that have to do with anything? Well, you could interpret a point xy to be the term number and the term value. So if you're like, well, this could be like the first term is 40. So like if it were a sequencer, it was 40 and then let's say 50 and 60, right? This is the first term. So this guy could be 140, right? And then what's our common difference? Well, our common difference here would have been 10. So, I mean, think about it. We could write it in point slope form. Y minus 40 equals the slope of 10 times x minus 1, which was our first position. And then we could rearrange that. If we added 40, this is now the explicit formula for this sequence, right? Where 40 is our first term, right? 50 is our second term. If we were to put a 2 here, 2 minus 1 is 1. 1 times 10 is 10. 10 plus 40, 50. So if you're like, whoop-de-doo, it is kind of a cool little comparison, okay? The other one we already kind of talked about. So that's, like I said, I tried to give you the really fast version of the notes where we didn't, I didn't give you much time for creative, like, pondering like we did in class. But there you go. A recursive sequence, a recursive formula for an arithmetic sequence. The explicit one is like this. We made that other one pretty. We gotta make this one pretty. There we go. Let me know what questions you got. The next video will be the assignment.